Hello, boys and girls. I'm back again today for a lesson on area. This lesson would be appropriate for really anyone who is just beginning to learn and understand area. It's targeted for third grade. All right, so let's talk about area. The first and most important thing you need to know is area is the inside of a shape. All right, let's read our learning targets. I understand that area represents the inside of a shape. I can count squares to find the area of regular and irregular shapes, and I can use multiplication to find the area of rectangles. What is area? When do we talk about the area of something? Well, anytime you're talking about the inside of a shape. So a rug, rugs you buy based on area, maybe a 5x7 rug or an 8x10 rug. Same with carpets, picture frames, paper. The paper that you use at school, notebook paper, is like 8.5 by 11 inches. You could measure the area of rooms, the area of gardens. The inside of anything would be the area. All right, so here's our first problem. Mrs. Lovell, that's me. I need to cover my bulletin board with paper. What measurements do I need? So let's say I'm going to use these units as my measurements, and I would pick them up and as neatly as I could, fill in the space with these squares. Notice that I am using squares to calculate area. So I would get all my squares and fill in the space of my bulletin board. And I would keep on going. I noticed that it's going to take 3 to go down, and it's going to take about 1, 2, 3, 4, 5, 6. Scoot that over a little bit. 7 to go across. So if I make my last row down here as neatly as I can. Okay. Almost got it covered. Let's get a few more squares on here. Okay, so now I have my bulletin board covered in units. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I would need 21 squares. 21 squares to cover my bulletin board. Now, let's notice something else. If I count down here, I have 3 rows. If I count across here, 1, 2, 3, 4, 5, 6, 7, I have 7 columns. And I bet already some of you are starting to notice if I were going to write a multiplication problem, I could say 3 rows of 7 equals 21. So already right now we can see that area has a lot to do with multiplication. All right, usually we calculate area by square units, as we said, and we can just count them if they're drawn for us. So for instance, in this rectangle right here, we could just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we could say the area of this rectangle that is also a square is 16 square units. 16 square units. All right, now what do we notice? We notice that this is a square and all the sides are the same and all the sides are 4. So we know that 4 times 4 equals 16, right? Okay, so we're starting to notice that there is definitely a relationship between the number of squares and multiplication and the length of the sides. So let's try this. Side 1, okay? Let's say that side 1 is this side along here. Okay, so let's count if we were going to do this side, how many squares we have. 1, 2, 3, 4, 5, 6, 7, 8. So side 1 is 8 units long. Okay, and now let's do side 2. Side 2 would be this side. And if we count side 2, just down like that, how many are we going to have? 1, 2, 3, 4, 5. We're going to have 5. So if side 2 is 5. Now, we can always find the area by counting if the squares are drawn. Okay, that's a sure method. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So what do we notice? That we have a total of 40 squares. And what is the relationship between 40, 8, and 5? Right, multiplication. We know that 5 times 8 equals 40. So we have 5 rows of 8. So we could say 5 rows of 8 equals 40, right? Okay. Let's look at this one. How much is side 2? We were going to count and put in how much is side 2, side 1 here of our first rectangle. Let's count. 1, 2, 3, 4, 5, 6, 7. So we could say that side 1 is 7. What about side 2? 1, 2. Okay, so side 2 is 2. 7 times 2. What is 7 times 2, everybody? Let's write the equation. Or actually, this one is 2 rows of 7 equals 14. So we know that in multiplication, because of the commutative property, we can switch the factors and get the same answer, right? We know that 2 times 7 or 7 times 2 equals 14. But this picture is of 2 times 7 because we have 2 rows of 7. So it's a picture of 2 times 7. All right, let's see what we have down here. All right, for side 1, we have 1, 2, 3, 4. And for side 2, we have 1, 2, 3, 4. This is a square. So both sides are 4, right? We got 4 here and we have 4 here. So what do you think our area is? We would say 4 rows of 4 equals 16. So our area is 16. And we could count to be sure. 4, 8, 12, 16. We could use our multiples. All right, so let's look at this giant square here, giant rectangle. See if we can figure out the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so across the top we have 15. And across the side, let's count what we have. 1, 2, 3, 4, 5, 6, 7, 8. All right, we have 15 and 8. So what would our multiplication problem be? It would be 15 times, actually, let's write it 8 times 15 equals, because we have 8 rows of 15. How could we solve 8 times 15 if we don't know how to do 2-digit by 1-digit multiplication yet? Anybody have an idea of how we could do that? Well, we could definitely use the distributive property, and we could break that 15 down, right? So let's say we break the 15 down into 2 more manageable and easy to multiply numbers. So we could break the 15 down into 10 and 5 because we know that 10 plus 5 equals 18. So we could think about, well, what is 8 times 10? We could say 8 times 10 equals what? 8 times 10 equals 80, right? And then we would have 8 times 5. And what is 8 times 5? We'd say, well, 8 times 5 equals 40. And then what are we going to have to do? We're going to have to add, and we're going to have to say 80 plus 40 equals 120. Now, we could count, you could count all 120 of these squares, but that would take a long time. It's a lot easier to just multiply, isn't it? And if we get a big number, we always can use the distributive property. And what's really cool is it's easy to show the distributive property with an array. In fact, it's kind of one of the best ways to show. So let's see if we could do that here. The first one would be 8 times 10. So let's count over 10. Let's get our pencil here and count over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if we draw a line down here, like this, okay, and we start with right here, this would be our first rectangle. Okay, and our first rectangle would be 8 by 10, which has an area of 80. And then our second rectangle would be 8. This is 8, right? Just like over there, if we go straight down, this is 8. Okay, 8. And across here we have 1, 2, 3, 4, 5. And 8 times 5 is 40. And so we're going to, oh, goodness, add together 80 and 40, right? We've got 80 over here, and we've got 40 over here. And if we add 80 and 40, we get 120. And it's a perfect example of why the distributive property works. It's called the area model to understand. All right, so now let's think about if we want to make a rectangle that is 6 units by 5 units, what would we do? Well, we want to have 6 rows of 5. So let's make 6 rows. 1, 2, 3, 4, 5, 6. 6 rows of 5. So 1, 2, 3, 4, 5. All right, if we fill this completely in, we would have a rectangle that is what? 6 times 5. And what is 6 times 5? 6 times 5 equals 30. What about if we wanted to make our rectangle with an area of 25? It would be a square, wouldn't it? What 2 numbers would we use? How would we do it? What do you think? Yeah, we could take one of these away right here, and now we would have 5 rows of 5, and that would equal 25. Exactly. Okay, so what is the area of this rectangle? Remember, you can always count. So why don't we start with doing that? We'll just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Okay, so by counting, we found the area of our rectangle to be 35 square units, right? 35 square units. Now, let's see if our multiplication would work. All right, so let's count across. We have 1, 2, 3, 4, 5, 6, 7. So we'll put a 7 up here. And if we count over here, we have 1, 2, 3, 4, 5. So let's put a 5 over here. And what do we know? 5 rows of 7 equals what? 35. 5 rows of 7 equals 35. Okay, so we could get it by multiplying the length times the width. All right, so let's look at these rectangles. Notice we don't have any squares, so we can't count here. We have to multiply. We're given the numbers. You can see we have the number 7 right here. This is a 7, so this side is 7 and this side is 3. So what would we do? Notice we also have a unit, feet. So it wouldn't be unit squared, it would be feet squared. So we would write our multiplication problem, which would be 3 times 7 equals 21. And our answer would be 21 what? 21 square feet. 21 square feet would be our answer for this one. All right, let's look at this one right here. Make this a little bit smaller so we can fit. Okay, we've got an 8 and a 4. So we would say 8 times 4 equal, oh, I forgot my times. 8 times 4 equals what? 8 times 4 equals, who knows? 32. Yep, 8 times 4 equals 32 square, and I'm going to abbreviate square feet. That's fine for you to abbreviate that way too. SQ for square and FT for feet. All right, here what do we have? We have 11 times 5, and that would equal 55 square feet. All right, I'm not going to do every problem on here right now. This is something you could practice with, but let's talk about knowing our multiplication facts. You're starting to realize that if you don't know your multiplication facts, everything that you learn from here on out is going to be a problem because you're going to have to stop and go back, count on your fingers, or do whatever you need to do to get the answer to the multiplication problem. And even if you understand area, that's going to take a long time. So it would be better if you knew your multiplication facts. So this is your little friendly reminder. You should be practicing your multiplication facts if you don't know them fluently. All right, so let's review what we've learned. We've learned that area is the inside of a shape. You can find the area of a rectangle if you know its length and its of the sides, and you understand that an area model is a model of multiplication, just like groups of and rows of and all the other things you've learned. All right, so let's make one quick rectangle here, and let's talk about a few things with it before we go. So here's one side. Here's another side. Let's do it. Oh, no, stop. Okay, let's make another side. Okay, another side. And the last side. But that's sort of a slanty rectangle. Let me fix that. And the last side of our rectangle. All right, so remember, you could count if there's squares. If there's not squares, you need to know the length. So let's say we have 6 and 5. Okay, you would multiply 6 times 5 to get your answer. And your answer would be 30 square units. If you're writing area on a paper, if you're taking any kind of test or anything where somebody's going to look at your work, if you don't use the word square, it's wrong because you're counting squares. So you would need to say 30 square units, right? It's important to remember to say that. Okay, so let's think about what we're multiplying. We're multiplying the length and the width of the square, right? One side is the length and one side is the width. So our formula for area, and this is a formula that you will use all the way through high school, is area equals length times width. All right, that is our introductory lesson on area. We'll be back later with more, but for now, that gives you a good bit to practice. Remember, I level math and I level you.